Hi everyone. Today we're going to study proof by mathematical induction. Proof by mathematical induction is a method to prove the theorem statement of the form P equals P of n. The n here is a natural number. We have a procedure to follow. Step 1. Show that the statement is true for the initial value of n. Step 2. Assume that the statement is true for n equals k. That is, assuming that p of k is true. Step 3. Show that that statement is true for n equals k plus 1. That is, showing p of k plus 1 is true. The principle of mathematical induction is this. If a statement is true for n equals 1, n equals k, and n equals k plus 1, then it is true for all n. By the way, the initial value of n is normally given in the statement of the theorem. Let us see example 1. Prove that for any natural number n plus 4 plus up to plus 2n equals n times the quantity n plus 1. Our step 1, we need to show the statement is true for n equals 1. What we're going to do, in our equation here, we will take the first value, the number 2, and that will be equal to the right side, and now we are going to change n by the number 1. So it will be like this. The number 2 is here, equals the right side, n becomes 1, times the quantity, the n plus 1 becomes 1 plus 1. When we simplify the right side, the 1 plus 1 becomes 2. 2 times 1 is 2. So we can see that the left side is 2 and the right side is 2. So the statement is true for n equals 1. Step 2, we assume that the statement is true for n equals k. What we're going to do, we will write again this statement theorem down here. We will change the variable n by k. So we will have 2 plus 4 plus the 2n here becomes 2k equals the variable n on the right side becomes k. And we are going to assume that this is true. Now step 3, we will show that the statement is true for n equals k plus 1. The procedure here is this. First, we are going to copy the left side of the equation, and it's here. Now we're going to show the next term for this 2k. That next term will be this 2k, but the k becomes k plus 1. So it will be like this, plus 2 times the quantity k plus 1. Now for the right side, this k times k plus 1, we're going to change the k by k plus 1 respectively. Now look at this k. We're going to write it here to be k plus 1. Look at this k inside the grouping symbol. We will write it also as k plus 1. And upon doing this, we're going to prove that this left side is equal to the right side. Simplifying further, the right side here becomes k plus 1 times the quantity k plus the 1 plus 1 becomes 2. So what we're going to do here is to keep the right side to be the same. We will manipulate our left side and find a way to show that this is equal to the right side. Take note that this expression from 2 up to this 2k is equal to our right side value here, and that is the k times the quantity k plus 1. And then we will copy the plus 2 times the quantity k plus 1 equals, the right side will just be the same. So we will simplify our left side. The k times the quantity k plus 1 now becomes k squared plus k. This expression here becomes 2k plus 2. Let us combine similar terms of the left side. This k plus 2k becomes 3k. So the left side now becomes k squared plus 3k plus 2. If we factor out this trinomial, we will get this k plus 1 times k plus 2. So we're able to show that this left side is equal to our right side. And we are done. We're able to prove that this theorem statement is true. This is the final answer. Example 2. Prove that 1 plus 3 plus 5 plus the quantity 2n minus 1 equals n squared, for n equals 1, 2, 3, and so on. Step 1. Let us show that the statement is true for n equals 1. We will take the first value of the left side, that number 1. Now for the right side, we will use the number 1 value here to replace the n. So the n squared becomes 1 squared. This 1 squared is simply 1. The left side is 1 and the right side is 1, and they are equal. We're able to show that the statement is true for n equals 1. Step 2. Assume that the statement is true for n equals k. We will copy this theorem statement, but instead of n, it will be replaced by k. So it will be like this now. 1 plus 3 plus 5. The 2n minus 1 here becomes 2k minus 1 equals, the n squared now becomes k squared. Step 3. Show that the statement is true for n equals k plus 1. We're going to write the left side, and then we will add the next term after the 2k minus 1. That term follows the same pattern, but for the k, it will be replaced by k plus 1. So it will be like this. The 2k minus 1 is the last term here, and we will add this plus 2 times the quantity k plus 1, then minus 1. For the right side, the k here will be replaced by k plus 1. So the k squared becomes k plus 1, and the quantity is squared. So we're going to prove that the left side is equal to the right side. Our next step is to substitute this expression here by the value of the right side of step 2. This is equal to k squared. Then we'll just copy this expression down here. So this value now becomes 2k plus 2 minus 1. Let us combine our left side members. So we have the k squared plus this 2k we copy down here. The 2 minus 1 is simply plus 1. If we're going to factor out this trinomial, this is of the form k plus 1 quantity squared. We're able to show that this left side is equal to our right side value. So we are done. We're able to prove that this theorem statement is true. This is our final answer. I hope you learned something from this video. See you again next time.